Now let's take it one by one. Now radius is an IETF standard, which is let's say described in RFC 2865. Of course, like any commonly used protocol, it has additional RFCs for specific features that came out after the initial version of the RFC. So like with any protocols for which there's an RFC, we always identify that the initial versions of the protocol didn't support all of the features that we need, because the network, the technologies are evolving and we need more features. And that's why in general pretty much each big protocol is going to have additional RFCs for additional specific features to be described. Now radius 1 drawback is going to be that it combines authentication and authorization in one process. So those cannot be two different processes. Let's see exactly where that's a problem. And radius runs over UDP ports 1645, 1812 for authentication. Those are and runs over UDP port 1646 and 1813 for accounting. Now the initial ports of 1645 and 1646, those are called legacy. The reason that we have new ports, which is 1812 and 1813, is because those legacy ports were also used by the data metric service. So in general, it's not good to have two services, well-known services running on the same ports. Like that's why HTTP runs on TCP port 80 and NTP doesn't run on TCP port 80. So each well-known service should have its own dedicated TCP or UDP, or both of them in some cases, port number that it runs on top of. So because initially the radius RFC was using the same ports as another service, the data metric service, then that's why they came up with also a new range of ports, 1812 and 1813. Now within the communication between the authenticator and the authentication server, because that's where the radius protocol is going to be relevant, within the radius packet, radius only protects or hides the user's passwords by using the MD5 algorithm. We're going to speak in greater detail about hashing and encryption algorithms tomorrow on VPNs. But radius is able to provide, let's say, security for the user's password by using a MD5 algorithm combined with a specific key, which is known only by the authenticator and the authentication server. So like for example, let's take this example, and assuming that SPCA telnets to router 3 to manage it, and it's going to provide a username and password in the telnet session. So TestPCA is going to say the username is, let's say, Christian, with the password being Cisco. So then router 3 receives those credentials, and it takes to put those credentials inside a radius packet towards the ACA server for validation. So these credentials are going to be sent Christian and Cisco, username Christian, password Cisco, are going to be sent by TestPCA over the telnet session to the router, and then the router 3 is going to put those credentials inside the radius packet. But now inside the radius packet, what's going to happen is that router 3 is going to put in there the username of Christian as it is, username of Christian, but the password is not being sent in clear text as it was as Cisco. Password is going to be a MD5 hash. I'm going to put in here a MD5 hash of the password, which was Cisco. So that's what router 3 is going to send within the radius packet. So that's why they state that radius protects only the user's password, because within the radius packet, everything is in clear text. If you do packet capture, everything is in clear text except the user's password. And in order to relay, so the router 3 is going to relay those credentials towards the radius server via radius packet. in order for the router to put the username and the password inside the radius packet, each of those alongside with other possible, let's say, other possible data that the router has to send over to the radius server via in the radius packet, everything is going to be put into what is called radius attributes. So I'm going to have the radius username attribute where the router is going to put the username of Christian, and I'm going to have also the radius user password attribute where the router is going to put the user's password in the MD5 hash format. And those attributes are of two types. Auto IETF standard defined, which means any implementation of the radius service should support those attributes, or they can be vendor specific attributes, like which is VSAs, which means that each vendor, including Cisco, has chosen to develop new attributes for different and various scopes. Like Cisco has developed a lot of let's say vendor specific attributes mainly used in order to assign different authorizations to a device requesting network access, like using a DACL or a per user ACL, or using voice domain authorization, or using what else, security group tag. So pretty much whatever is, let's say, proprietary to Cisco, most of them are going to be, if they have to be sent via radius, they cannot make use of radius standard attributes, because those are Cisco proprietary, let's say, features. They're going to make use of Cisco's own vendor specific attributes.